Just realised what I omitted to do, and that was take a pass across here, because I don't know that that is at right angles to these two surfaces, and we need to take a bit off that anyway, because when we mount rolls on there, this just sticks out too far, so we need to take several millimetres off there. No doubt about it. Carbide cutters perform infinitely better than high-speed steel. So bang for your buck. This one came from China and was about 1/5 of the price of a high-speed steel cutter. I'm just going to do a climb pass in the other direction. Okay, so I've remachined the bottom surface, the surface that's sitting on the granite, and I've got a dial gauge here, and it's 0.01 divisions, 0.01 millimeter divisions. So each minor division is 0.4 of a thousandth. So as you can see, that bottom surface is dead flat, and it's not moving at all. Just see if I can move the camera a bit so you can read it a bit better. No, that's worse. You have to take my word for it. Anyway, the needle isn't moving from side to side, so I've got to be careful that I don't bump that. So the reading we've got here is 12.28, so sorry, 12.30 millimeters. 12.30, just check that again, yes, it's in the same place. So 12.30. Now we'll come up to, gently come up to the top position. And we'll adjust the micrometer to read the same reading. Which is there. Should be a 0.01 high. Right there. And that's not moving either, so that is flat from side to side. And our reading here is 88.10. Right, so it's 75.8 millimeters according to this measurement. Right, so what we've got here is a 30 millimeter gauge block. .58 30.60 30.60. Right, so we're now going to ring a 50 on top of that. And it's rung. I'm going to gently move this up so we don't disturb it. Lock the top, bring this down to the same position. Just right there. Okay, we're good. And the reading is 80.68. Right, so the difference between those two was 50.08. So we added 50 on top of the gauge block. We should have got 50 difference. We got 50.08. 0.08 of a millimeter is 3.2 thousandths. That is wildly different. Okay, so what this is showing us is that this instrument is under reading by 0.08 millimeters over a 50 mil range. So when I said that this was 75.7, it was actually 75.78 based on that calibration, which means that I've got to take 0.78 of a millimeter off either that surface or that surface to get this off that surface or that one to get this sine bar accurate. So I'll just repeat that. So I measured this sine bar, and it told me that it was 75.7 between there and there. Okay, so I've got the workpiece in the vise levelled, the parallels are tight. I've got to take 0.72 off that surface there. I don't want to lower this benchmark at all, so but I don't actually have to go right down to that surface because the rolls won't touch the inside corner, obviously. In other words, when I got that in there, the very inside corner down in there is not going to contact the rolls. So I'm going to use a piece of cigarette paper to determine when I'm down a thousandths above that bottom surface. So I'm just going to stick a piece of cigarette paper, stick a piece on an oiled surface, and when the paper disappears I know I'm a thousandths above that bottom surface, and then I'm going to do the same with the back surface. So I'll stick the back bit on first so I don't get my fingers in there. Okay. So according to theory, we're 1/1000th off that surface, and we have to take 0.78 of a millimetre off, including plus 1/1000th. So, and we'll do it as a climb pass, so we get a better surface. So 0.2, 4, 6, 7, 8 plus 1,000 right there. What totals? And we'll do it dry because if it's so that the shavings fall out of the cutter. And it's still raining. Right, so that's a very nice surface, and we should be spot on at 75 millimetres. So let's go and measure it. I'll measure this top one first, seeing we're up here. Unfortunately, you can't see the dial, but you're going to have to take my word for it. So what we're doing is we're lowering the indicator, and the reading at the bottom is 12.08. Right, according to that, that surface and that surface are 75.02 millimeters. So my sine bar is 0.02 millimeters too long, and that's 0.8 of a thousandth. I don't think I'll try and get rid of it. I could possibly stone it off, but I don't think I'll try and get rid of it because we've still got to add the two rolls yet, and we're liable to get an error there. Right, so what we're going to do now is put it in the shaper and machine off that surface there at an angle of 45 degrees or thereabouts, just to allow for clearance for the gauge blocks. I didn't do that earlier because I didn't know whether this was scrap or not. It's now not scrap, so because we've got those surfaces pretty good. So we'll machine that off now, and I'll write that measurement down, and we'll stamp that measurement on the finished product. Okay, so let's now mount that in the shaper and get rid of that excess material. Another point to note, that the depth of this slot here, this slot from there to that surface, must be greater than the radius of the rolls, so that the roller diameter is against that surface. Obviously, if that slot's not deep enough, then the roller is not resting against the surface in the correct manner. Far enough. And we'll take another 10 thousandths. Probably take more than that. The reason I'm cutting this dry at the moment is I can't find my lubrication tin of oil. But it's doing a nice job. And 5, 10, 15, 20 thousandths. very nice surface, that. There's a little bit of scoring going on just on that edge there where the tool is lifting to come back, which is a problem with shapers. I could probably get rid of it if I increased the travel a bit so that the reversing happens further away from that edge, but I don't want to risk damaging that surface there. Okay, so I think we're done now. Pity about that little ding just there. Okay, so we'll deburr the whole thing, and then we'll mount the rolls and then finish this top surface. Now I'm going to glue the rollers in. I know that's not traditional, but they put aeroplanes together these days with epoxy, and probably most of you will know that the windows in most high-rise buildings are glued in place with double-sided tape. So if we can glue a window in or glue an aeroplane together, then we can certainly glue these rollers in place. I glued this one and it worked out well. So let's clean it up and get it ready for the adhesive.